Welcome to doassignment-ca. Here is the problem. A disk is originally rotating at omega 0 equals 12 radians per second. It is subjected to a constant angular acceleration of alpha equals 20 radians per second squared. Determine the magnitudes of the velocity and the normal and tangential components of acceleration of point B when the disk has undergone 2 revolutions. Point B is located at a radius of 0.4 meters from the center. Now, let us work through the solution step by step. First, convert the 2 revolutions to radians. 2 revolutions times 2 pi radians per revolution gives 4 pi radians, which is approximately 12.566 radians. Here is a diagram of the rotating disk. Point B sits at 0.4 meters from the center O. The orange arrow shows the tangential velocity of B. The blue arrow points inward toward the center and represents the normal acceleration. The green arrow points tangentially and represents the tangential acceleration. The disk starts at omega 0 equals 12 radians per second and has a constant angular acceleration of 20 radians per second squared, undergoing 2 full revolutions. Use the rotational kinematics equation omega squared equals omega naught squared plus 2 times alpha times theta. Substituting 12 squared is 144, and 2 times 20 times 4 pi is 160 pi, which is about 5.2655. Adding those gives omega squared equals 646.655, so omega equals the square root of that, which is approximately 25.43 radians per second. The speed of point B equals the radius of B times the angular velocity. That is 0.4 meters times 25.43 radians per second, giving a velocity of approximately 10.17 meters per second. The tangential acceleration equals the radius times the angular acceleration. That is 0.4 times 20, which gives 8 meters per second squared. This acceleration acts tangentially to the path of B in the direction the disk is spinning up. The normal or centripetal acceleration equals the radius times omega squared. Substituting 0.4 times 646.655 gives approximately 258.66 meters per second squared, directed toward the center of the disk. Here is a summary of all results. After 2 revolutions, the angular velocity reaches 25.43 radians per second. Point B has a speed of 10.17 meters per second. Its tangential acceleration is 8 meters per second squared, and its normal acceleration directed toward the center is 258.66 meters per second squared. The total acceleration magnitude of point B is approximately 258.78 meters per second squared, with the normal component dominant because the angular speed is relatively large. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.